Welcome to the Professor's DuBois channel. This is Professor Corey, and this video is a mini lecture based on our second lecture covering material from Chapter 4. This is in no way equivalent to our actual lecture, where we discuss and practice the material in much more detail. We begin this lecture with a little review on how salts and molecular compounds dissolve in water. When sodium chloride crystals are dissolved in water, the polar water molecules exert attracting forces which weaken the ionic bonds. The process of solvation occurs when the ions of sodium and chloride become hydrated. Sugar is not ionic. It is considered to be a molecular compound because the elements that compose sugar are all nonmetals. It does dissolve, but it does not dissociate into ions. In summary, we conclude that soluble ionic compounds will form ions in aqueous solution while most molecular compounds will not. But we cannot see ions, so how do we know that this is true? The answer lies in the ability to conduct electricity. Pure water does not conduct electricity because it doesn't contain ions. Ions, specifically cations, that have positive charges, carry the electrons in solution. The flow of electrons is called electricity. To make an aqueous solution that conducts electricity, a soluble ionic salt can be added. A strong electrolyte is a compound that, when dissolved in water, will completely dissociate, meaning that it will ionize completely. Examples of strong electrolytes are soluble ionic compounds and strong acids. You can determine if an ionic compound is soluble by using your solubility chart. There are 6 strong acids, and these will have to be memorized. Non-electrolytes are compounds that dissolve in water but do not dissociate into ions. We call these non-electrolytes. They are typically molecular compounds. However, there is an exception for acids and some weak bases. Weak electrolytes dissociate to a very small extent. They are categorized as weak acids or weak bases. The only base that you will need to identify is ammonia. The best bet for identifying weak acids is to look at the first element in the compound. Most acids begin with hydrogen, so if it begins with hydrogen and it's not one of the 6 strong acids, then it is very likely a weak acid. Are the electrolytes in your favorite sport drink the same thing that we're describing? The answer is yes. Salts are added to sports drinks to replace the ions lost during exercise or while playing Little League Baseball. Americans spend a lot of money on these drinks. Notice that whole milk contains a lot of the ions that are common in a sports drink. This is likely the reason that chocolate milk is considered to be a very good recovery drink after exercise. We stated earlier that strong acids and soluble ionic compounds are strong electrolytes. There are 6 strong acids that you will have to memorize. Notice how they all begin with hydrogen. If a compound that we ask you about begins with hydrogen and it's not one of the strong acids, consider it a weak acid. Weak acids and bases will dissociate, but to a very small degree. The weak base that we will use often is ammonia. Not all elements or compounds will react. Something needs to drive the reaction. Formation of a pure solid, liquid, or gas will drive a reaction to occur. We will start by examining precipitation reactions. A precipitation reaction forms a pure solid. This can be observed visually. Let's begin with a double displacement reaction type. To predict the products, we will switch the cations of our 2 reactants and form neutral compounds as products. If one of the products is insoluble in water, we can label the type of reaction as a precipitation reaction. On the top reaction, notice that I wrote the ions that form the reactants above the reactants themselves. This helps me to visualize switching the cations to predict products. Once the products are predicted, I put a line through those ions so that I don't get confused later. Sodium and bromine will combine in a 1-to-1 ratio, forming sodium bromide. There are 2 fluoride ions needed to combine with calcium to form a neutral compound. Next, I'll go to my solubility chart to see if either product will form a precipitate or is it insoluble in water. The next step is to balance the equation. Another note, the positive ion always comes first in a compound, but the order of the compounds in the equation is not important. Predicting products and determining the solubility will require practice. You should be comfortable doing this before the next lecture, where we will turn this molecular equation into a net ionic equation. Thanks for watching. Please give this video a thumbs up and subscribe if you would like to see more mini lectures on the Professor's DuBois channel.